All right, I want to just touch on a couple little points from this last example, okay? Because maybe some of you are a little bit rusty on your algebra, and I just want to make sure you don't make some critical mistakes. The first kind of mistake I mentioned is right here. Like, let's say you're given h minus 5 squared. Something like that, okay? A lot of students think that you can just bring the square onto each of these and maybe write this as h squared minus 25. Or maybe they write h squared plus 25 or stuff like this. This is totally wrong, okay? If you ever are not sure how to square, this is called a binomial, okay? Because there's two terms here, and we're squaring a binomial. What you should do is you just can multiply it by writing it 2 times beside each other, okay? And you got to remember, there's really 4 terms here. So h times h is h squared. That's the first terms. The outer terms would be minus 5h. The inner terms here would be another minus 5h. And the last term would be minus 5 times minus 5, which is plus 25. So we get h squared minus 10h plus 25, which is what I wrote down here. So just be careful about that, because I see this kind of mistake all the time, and we don't want to make that kind of mistake. So kind of, if you want to memorize some rules, a plus b squared, please don't think that that's a squared plus b squared, okay? That's totally wrong. There's another term in there. It's actually, there's 3 terms in there, and it's a squared plus this times 2, okay? So 2ab plus the square of the last guy. And what about a minus b squared? This is not equal to a squared minus b squared. It's not a squared plus b squared, nothing like that. It's a squared, same thing, a times this times 2. So a times negative b times 2 is minus 2ab plus b squared. So whenever you come to multiplying out something like this, you have 2 choices. Either write it beside each other like we did and FOIL it out to get 4 terms, or remember this little formula here, okay? But just make sure you multiply those out correctly. Now I want to talk about next an even more common error, which is the step that basically we did right at the end. From here to here. Okay, look what I had here. I had h squared minus 10h over h. Now I know a lot of you think that you can do this, right? You think you can cancel these h's right here, and this is equal to, you think h squared minus 10, okay? That's totally wrong. Because you're probably used to maybe something like this. Maybe you have h squared multiplied by 10h all over h. Then you can cancel them, okay? So why can you cancel them here, but you can't here? Well, the reason is this is multiply, right? And this is a subtraction. When it's add or subtract here, you can't just cancel it off one of them. You have to actually cancel it from everywhere. But when it's a multiply, then you can cancel it off one. You could cancel these 2 guys, or you could cancel an h here and one of the h's there, and you'll get the same thing in the end. Now this is supposed to be videos on calculus, so I don't want to spend too much time talking about algebra, but I just want to talk about these common mistakes a little bit, okay? So let's go back, and I'll show you a kind of a safe way to do this, okay? You should remember that if there's like an add or subtract here, you have to have an h everywhere, okay? There's an h there, there's an h there, and there's an h there. So I'm allowed to cancel, okay? But maybe a safer way to do it would just be to go like this. On the top, factor out an h. So you get h minus 10 on top, and then on the bottom h. And then your instincts will take over, and you'll cancel off those h's, and you'll write h minus 10, which is what you should have, okay? So I hope that makes sense. So like if you have something, if you have an expression like this, maybe like x squared plus 3 over x, please don't think that you can cancel off an x here, okay? Maybe you think, well, this x goes away, and then one of those x's goes away, so we're left with x plus 3, okay? That's totally wrong. You can't do that. If instead you had something like this, maybe x squared plus 3x over x, Do you see how there's an x in every single term then? In this case, then you can cancel off an x. And if you want to be really safe, just factor out the x first before you cancel, and then you won't make that mistake, okay? So you're left with x plus 3. In this case. In this case, you can't do anything, but in this case, you can. All right, good enough for that. So I hope some, because these kind of little algebra things are going to come up all the time, and you really need to be aware of that. Maybe another little algebra thing is this: what is root x times root x? We covered that really fast in the video on rationalizing there when we, like root x times root x, I hope you know, this is root x multiplied by root x is x, right? So in other words, the root of x squared is x, okay? And let's try one of the kinds of where we have to rationalize, okay? How about the limit as x goes to 9 of 9 minus, well, we kind of did something like that already. Let's do a little harder one. Limit as x goes to 0 of the root of 2 minus x minus root 2 all over x. Okay, so let's put x in real quick to see what we have. Here, when we put x to be 0, and we get 2 minus 0, so 2, and so root 2 minus root 2. So the 0 on the top and 0 on the bottom. So it's 0 over 0, so we're type 2. We can't factor this, so we should use the other strategy, which is rationalizing. And just to save some time, I'm just going to multiply the original question here right away by my good choice of rationalizing, okay? Now look, this is a minus here, right? So basically what I want to do is I want to recopy this expression on the top and bottom, but I want to use a plus instead, okay? So we're going to write the root of 2 minus x plus root 2. And it has to be exactly the same on the bottom, because having the top and bottom being the same on this fraction means this is really a 1. And multiplying by 1 doesn't change anything. This is probably you've probably never seen you've probably never seen 1 written in such a strange way. But truthfully, this over this is just equal to 1. Now, let's multiply this out, okay? So let's see what happens. Root of 2x minus the root of 2, the root of 2 minus x times the root of 2 minus x, just like up here, that's just 2 minus x. And notice the outer term and the inner terms, those cancel. This is a positive and this is a negative, and those cancel, so they just disappear. I don't even have to write it. And at the end, I have minus root 2 times positive root 2. So that's minus 2. And on the bottom here, don't multiply the x across, okay? You could, but that would kind of wreck what you're striving for here. Let's leave it factored. And notice what happens now. 2 minus 2, those go away. So on the top, what are we left with? We're left with minus x. And the bottom, I'm just going to recopy. There's a lot of recopying in calculus and math in general. Notice that I'm still writing my limit sign out front, huh? I haven't gotten rid of my limit sign yet because I haven't done the limit yet. Now look, we're happy because these x's cancel, huh? After these x's cancel, this is no longer going to be a 0 over 0 limit anymore. This is going to be an easy kind of limit again. So it's the root of 2 minus x plus root 2 plus, and then, so now you know what? We can just put 0 in, can't we? Because no longer is it 0 over 0. This is defined now. So I have the root of 2 minus 0 plus root 2. Well, the root of 2 minus 0 is just root 2. So I get negative 1 over 2 root 2. And that's my answer. Okay? Maybe you could rationalize that, but who cares? So that's the end of this video.